The weight W of a body varies inversely as the square of its distance D. So let's take this gently. The weight that's of W varies inversely, that is 1 over the square of its distance, the square, that's D raised power 2, from the center of the earth. That means D represents the distance from the center of the earth. This expression could also be written as, I have this as W varies as D raised by minus 2. D raised by minus 2. But it is better written in this form. It is better written in this form. So let's just take this out. Alright, so the weight W of a body mass varies inversely. Varies inversely. The weight W varies inversely as the square of the distance. The square of the distance represents the distance from the center of the earth. A body weighs 18 Newton on the earth's surface if the radius of the earth is 6,400. And so we are going to make this expression something more operational. This is just symbolical. And so this is going to be W equals to, we introduce a constant term, K times 1 over D square. And that is W equals to K over D square. And so we have been told that a body weighs 18 newtons on the earth's surface if the radius of the earth is 6,400. Remember that radius represents the distance from the center of the earth. The distance from the center of the earth, and that's the radius. So we're going to substitute this. Our weight, that is 80, equals to K divided by 6,400 square. When you evaluate this, that is going to give us 80 equals to K divided by 6,400 square. That's about 14,960,000. So the value of K here, when you cross multiply these two expressions, these two fractions, you have this as 327,680,000. So you have this as 3,276,800,000, and that's the value of the constant term. So again, now to answer this question, calculate the distance of the body of 20 newtons from the center of the earth. Calculate the distance, that means calculate D. So first of all, we need to get the equation connecting all of this together. So we say W equals to 3, we're substituting for the value of K now, 327,680,000. All of these divided by D square. So now, calculate the distance. That means calculate D. Get the value of D. So, we are going to have this as W. The value of W is given to us. The weight of the body is given to us as 20. So, I have this as 20 equals to 327,680,000. All of these divided by D square. When you cross multiply these, we have this as 20D square equals to 327,680,000. And so we have this as D square will be equals to 327,680,000. All of these divided by 20. So this will be this. D will be equals to the square root of, when you take out the square on one side, you find the square root of the other side. So when you divide this, we have 1,638,400,000. And so we find the square root of this. D, which is the distance, will be 12,800 kilometers. The next question, calculate the weight of the body which is 1,600 kilometers above the surface of the earth. So here we asked to calculate the weight. So we have our W. Remember, we already obtained the equation, which is W equals to 3276,800,000 divided by D squared. And so our W here, we are substituting the distance. The distance is given to us as 1,600 kilometers. So this is going to be 3276,000,000. All of these divided by 1,600 square. So let's evaluate that. This will give us 3276,800,000 divided by 1,600 is about 256,000. And so our final answer, the weight of the body will be 1,280.